Well, thank you for sticking it out for so long. You shall be rewarded with wine and beer in 2 talks, half an hour from now. Well, as we have seen, volcanism is rather important in mass extinctions, and we are trying to understand both the mass extinctions and the volcanism. But it was also important culturally in India, as you can see from this picture, which shows the Ajanta caves, which were dug into Deccan trap lava flows between 200 BC and 650 AD. Okay, wait a minute, there we go. The work that I'm showing you is from a large number of people. Many of them are shown here, but there are also others that are not. I just want to mention a couple of people. Thierry Haddad, my long-term collaborator, is there, as well as in the lower right-hand corner, my 2 graduate students who are in the audience here and trying to run around giving you the microphone for questions. The main objectives of our going to India to look at Deccan traps was to find the KT mass extinction relative to these traps, to see whether there really was a direct relationship between the extinction and the volcanism. And we've succeeded in that. We wanted to evaluate the climate change on a global basis. As a result of Deccan volcanism, and from there look at the biologic changes on the global basis and see whether they tie in with the Deccan volcanism. And finally, of course, to see what is the role of Chicxulub in the mass extinction. So these are some of the localities in red on the upper left-hand corner. And the types of environments we looked at is both the high Deccan traps as well as for the mass extinction in particular was in the Krishna Godavari Basin, which is around here in Rajamundry area. What I need to tell you first about as background for what we are going to see now is essentially that the Deccan traps occurred about in 3 main phases: a very small phase in the late Maastrichtian around 67.2 million years, a main phase with about 80% of the trap eruptions just before in Cron 29R, essentially before the mass extinction, ending with the mass extinction, and the last phase in the early Danian, Cron 29N. Now, we will just talk about the main phase of the extinction here. In particular, we have got the best age date from a number of cores in the Krishna Godavari Basin taken by India's National Oil Corporation, Oil and Gas Corporation, ONGC, and also from quarries in Rajamundry. These are a number of the cores from the oil companies and was correlated through the down core hole logging. And the purple color is the last phase, phase 3, in the early Danian, and the orange color are the lava flows from phase 3 here in Rajamundry. These are considered the longest lava flows on Earth, possibly having run over 1,000 kilometers across India and then out into the Bay of Bengal. What you see in between here are the intertrappants, sediments which document the mass extinction. So we actually can get information one-to-one between mass extinction and the traps. So This is a composite of 9 wells that we analyzed, and they're essentially middle shelf faunas. And what you can see by the time, it's a pretty normal shelf fauna, but after the first mega lava flow that hit this area, the fauna is decimated, leaving just a few species, and there is no recovery. And by the time of the 4th and last lava mega flow, the mass extinction is complete. But we can also go to the northeast, which is about in Meghalaya, which is about 800 kilometers from the Deccan Volcanic Province. And here we have a really nice record showing the delta C13 shift, but also a large iridium anomaly of about 12 parts per billion and other PG anomalies. But when you come to the fauna, it's 95% is essentially consisting of this one disaster opportunist, Gymbeletria cretaceae, and the rest are just sporadic presence of other faunas. There's a lot of dissolution through here, and we think that's due to acidification. The species themselves are dwarfed, but there is also gigantism, in particular in some of this area, possibly due to the water quality. Now, what I want to take you is out of India and see what could the climate record have looked like. Of course, we know for many years, a lot of people have documented a rapid climate warming in Cron 29R below the KT mass extinction, and attributed this to Deccan volcanism, simply because there wasn't any other source of CO2 that could have caused this warming. What I'm going to show you now is a high-resolution record from LS, Tunisia, where we have an average sedimentation rate of 8.6 centimeter per 1,000 years for Cron 29R. And the sample resolution here is, on average, 1 sample every 10 centimeters. So it's, for the last part here, the last 80 centimeters before the mass extinction, we have at 5 centimeter intervals and 3 and 2. So the resolution then on average is around 1,140, or wait a minute, where are we here? So around, on average, sample spacing every 570 years for the last 80 centimeters, and the rest is about 1 sample every 1,140 years. You will also see that it's rather negative, and this is essentially through the eastern Mediterranean, from Egypt, Israel, Egypt, Sinai, to Tunisia, and it is diagenetic overprint, but the trends are there, as I will show you very shortly. So this is the actual record, the longer record with the carbon-13 also. The data is for planktic foraminifera, Rugoglobicrina rugosa, and a benthic species. This one is a very well-known record from Deep Sea Site 525A in the South Atlantic, and you can see the same record, the same planktic and benthic species. The warming in here in the benthics, same as over here in LS, the same trends. And the planktic record is similar. However, this is a record that's 4 times the sedimentation rate to the deep sea. When we look at the faunal record at LS, picked here are the most abundant ones, species, which are, of course, only the ones that are resistant to environmental changes, except for this one, which is the Globotruncanets, and they show a strong decrease throughout the latest Maastrichtian. But when you look at the overall diversity, there is a gradual decrease until we hit this top here, and then it drops. So what I missed pointing out in the last one are these two very sharp warming events. One is at the beginning of Cron 29R, coinciding with the beginning of phase 2 Deccan volcanism. And the second one is at the ending, about 10,000 years before the mass extinction, where we have, again, a very rapid increase in temperature and coinciding with the mass extinction. At the same time, we have ocean acidification associated with this warming, and the disaster opportunist, Gimbelitria, is taking over, while everything else is going to extinct. We have a similar record at Texas, at the Brazos section in a core that we drilled there. Down here at this level, which is the zone CF2 level, is equivalent to the base of Cron 29R. And we have some warming trend, but again, in the upper part, we have a more rapid warming, in this case to the left, because the standard plotting here. So it does happen. It is not evident in this warm event. Is not everywhere apparent in deep sea sections. In fact, it's in very few. But we can now identify them also on based on faunas. The reason it is not there is simply because most KT boundary sections are not complete. And while more is missing in the early Danian, there is also some erosion, usually of the top Maastrichtian, just as there was in 525A, which I missed pointing out. What is interesting, though, from Brazos, and the real reason I'm showing you this, is that there is a sandstone complex in a submarine channel with impact spherules at the base, and that has been by some interpreted as the KT boundary, but it is actually predating that. It is not. It is obviously a reworked deposit. I will get back to that again later on. This is going back to the Brazos fauna, and what you can see again is that there is a dramatic decrease in diversity associated with this warming, what we now call a hyperthermal warming, and it's the extinction is after this event. Now, I'll take you back to northeastern Mexico, and this is an attempt to figure out just where and when the Chicxulub impact occurred. In northeastern Mexico, there are a few sections that cross the boundary, and this is one of them, showing again the rapid decrease in extinctions and the hyperthermal, associated with the hyperthermal, and the increase in the disaster opportunists. But below that, and this is the La Parida section, and this one is farther away because wherever we have these kind of sandstone complex, it is on table mountains, and there is usually no sediments above it, so you have to go down into the lower parts to find the boundary itself. But the sandstones complex, which is often identified as the KT boundary, consists of, in this case, about 14 meters thick. It has highly bioturbated sandstone, shale, and sand layers. And below it, there are two spherular layers, all reworked with a lot of shallow water debris, and and the limestone in between with some burrows. We found about 4 meters below, at this Alpenion section, up to 2 meters thick impact spheroidal layer. And we believe this is the primary layer for reasons I will show you in a minute. But for now, let's concentrate what the species look like above in abundance and otherwise above and below this spheroidal layer. And you will see that there are no significant changes that we could actually point a finger to. So I will take you now to this impact spheroidal layer, and these are some of the types from the bottom to the top. And you can see in the bottom there is a lot of welded glass. They are sort of in 10 centimeter thickness, and some have inclusions of forams. And then we have also vesicular glass, oval, supposedly once spherules compressed from the heat, dumbbell shell, concave, convex contacts, and then on the top, and of course the actual spherules that are not compressed. But what you see in all of these is that the interstices are calcite cement. So there is no debris, there is no shallow water, there are no shallow water forams, there is no reworking in it. So it suggests that these deposits were actually perhaps cemented on the surface and came down as rafted debris very quickly. If we go back to Alice and look at the impact, well, I'm going back to this one and point one more thing out. When it comes to the age, this is zone CF1, which spans approximately the last 150, 160,000 years of the Maastrichtian. And in all of the sequences, which I will talk in more detail on the Tuesday section, we have the oldest impact spheroidal layer near the base of this zone. So if we go back to the LS record again with the climate curve, we would, the Chicxulub impact would fall essentially halfway down the phase 2 Deccan volcanism, so just about in the middle. We can summarize these criteria then in terms of, well, we have a cooling event just before, near the top of Kron's 30N, before we hit 29R. And it is the coolest interval of the Cretaceous. And right after that, we have Deccan volcanism beginning, phase 2, and this hyperthermal warming. You stay relatively warm, and we hit the Chicxulub impact at about this interval. Now, that may have added to the warming there, but we don't know yet. But it's certainly quite possible. And then about 10,000 years before the mass extinction, we have this hyperthermal warming again. We have the mass extinctions are very rapid, concentrated in that interval. And we correlate this to the mega eruptions at the end of phase 2, which are those longest lava flows that we identified in the Krishna-Godavari basin. You can see that with these hyperthermal stress conditions here, the Gymberitria, very disaster opportunists, increases dramatically, and the other ecologically tolerant guys, which is only the bicereals that are still common, also are going extinct, leaving essentially just Gymberitria. So we conclude then that Deccan phase 2 caused globally rapid climate changes with the onset and ending marked by hyperthermal warmings from about 4 degrees, at least 4 degrees, based on not the LS section, but at, for instance, site 525A. The end Cretaceous hyperthermal event occurred over just about 10,000 years based on the sedimentation rate and coincides with the time of those mega eruptions and coincides with the global mass extinction. The hyperthermal warming and ocean acidification also coincide with that KT mass extinction. The Chicxulub impact crashed into Yucatan during the upper or middle part of phase 2 volcanism, about approximately 120,000 years before the mass extinction. So far, we could not say that Chicxulub caused any the end Cretaceous mass extinction, though we don't know what if there were any long-term effects that are recognizable. Thank you.